Hey there, welcome to Snowpal Software Development and Architecture Podcast. In today's podcast, we're going to take a look at Confluent Cloud. Uh, I actually did an entire recording, believe it or not. It was about an hour, where where we, went through uh, took Confluent Cloud as a technology to explore, as a service to explore, if you will. We signed up for service and checked out a few things, like we almost always do in our podcast, in the solo technical podcast, where we share technologies that we use at Snowpal and other technologies that we have not yet consumed, but we likely might consume in the near future or the near to midterm future. And the process typically is, we have seen the other ones, you'll know if folks haven't seen it, hit record and then we start exploring it. There's not any preparation that's been done before, and intentionally so, because the idea here is to learn together with somebody who may or may not actually be here physically, right? Or through somebody who's connecting to this podcast. I did that. As it turns out, I don't know if I ran into a bug with the tool I'm using, or whether I actually did not hit stop share somewhere during the course of the podcast. Long story short, 25 minutes in, it was just me, my face, and not the actual screen, which is not particularly helpful when you're doing these hands-on podcast sessions. So I'm just redoing it. It's never going to be the exact same thing as learning it the first time, which was like an hour ago. So I'm 1 hour. My experience with Confluent Cloud is about 60 to 65 minutes, if that. So I'm going to go back to some of what we did, and do a fresh recording again. So it's going to be a little bit different from the usual process, simply because this is a second attempt at doing the same thing. So I might be a little bit more familiar, like a 60 minutes more familiar with Confluent Cloud than I probably was an hour ago. With that said, and without further ado, let's get rolling. I'm going to actually hit share. Hopefully, this time it does it correctly. Okay, it takes a second. It's going to start sharing my screen. I will get ready while it does that. That's taking an awful amount of time. Let me stop. Tool does sometimes have a couple of glitches. Okay, now it is sharing. Okay, cool. So we're going to look at Confluent Cloud. What is Confluent Cloud? Let's see what that is. Confluent Cloud. I'm going to do some of what I did an hour ago, literally try to repeat it, do a tiny bit of acting, if you will. But this is exactly what I did like an hour ago, because I did not know what Confluent Cloud was. I stumbled into it yesterday, and I was curious to know what it was, and I want to look it up. So what it essentially is, it's a fully managed Kafka service. It's managed Kafka service. Uh, I've done a fair bit of work with Kafka. At Snowpal, we use RabbitMQ for most of our messaging needs. We are porting over to Kafka slowly but surely. So that's just a quick background of my experience with something like RabbitMQ, Kafka, and back in the day with ActiveMQ and a lot of these other message brokers. Confluent has Confluent versus Confluent Cloud. Confluent Cloud is basically Kafka as a managed service. You could use Confluent without the cloud part, which is you provisioning it in your own infrastructure, probably in a data center or something along those lines. Now, what is Kafka? We don't want to go into the details of Kafka. The assumption here is you know what it is, or have used it some, maybe a lot more, maybe not a whole lot, but at least you have an idea. If not, please definitely look it up before you. Not that you need to know that for the rest of this podcast, but it wouldn't hurt. Kafka, and I'm going to read out from their documentation. It's an open source distributed event streaming messaging platform. It's very performant. So if you're not using it, if you want to do asynchronous message processing, Kafka is probably one of the top options that there is out there. Now, how you consume Kafka is entirely up to you. You could actually, hopefully, am I sharing it? Yeah. Hopefully, it's recording it correctly this time around. How you consume it, how you provision it, it's left to you. Confluent Cloud, I believe, is like, it's Confluent Cloud is to Kafka as MongoDB Atlas is to Mongo, if you know what I mean, because I've done some podcasts on MongoDB, which is what we predominantly use as a persistence layer at Snowpal. It's created by the founders, by the creators of Kafka, but it's the paid version of the open source Kafka. So it brings some value add and differences. Uh, so you actually, which is why, let's look at some reasons why you might not use straight up Kafka and use some of these managed providers. It's because it actually provides added value, like I said earlier. But what does added value mean? Pre-built connectors. There's a lot of connectors. We're going to look at one of them and maybe more as we go along. This is going to be podcast number 1 in the series 1 of N in the, let me call it the Confluent Cloud series. We did some on Salesforce not too long ago, and then did I think 6 or 7 on Salesforce. Definitely check it out if you haven't seen it. All of it is hands-on stuff. After that, I think we did a couple on Terraform. There's a lot more to go with Terraform, obviously, and there's a lot more to go with any of these things. But at least, we do initial podcast to skim the surface, and then we can keep chugging along. That's why it's numbered 1 of N, 2 of N, and so on and so forth. Now, once you decide that you actually want to use Kafka, and you want to figure out which direction to go, whether you want to use a managed provider, managed Kafka, or otherwise, even if it's managed Kafka, which provider, there are a few options. And as is always the case, Amazon has something called, I think is MSK is what I think. I just looked it up. Yep. Amazon, manage streaming for Kafka. So Amazon, a lot of these cloud platforms have a competing offering for just about anything that you can think about out there. Now, do I recommend you use that? It's left to you and your needs in the companies. I know some companies are like, don't mind vendor lock-ins. They prefer everything to be provided by a particular vendor, whether it's Google Cloud or Azure or AWS, the 3 big players. At Snowpal, we use cloud solutions as one of the ways to solve problems, not the only way. What I mean is, obviously, everything we do is on the cloud, but I meant cloud providers like AWS, Amazon, like Azure and Google Cloud. We use a variety of different tools and technologies. Of course, all of it is in the cloud, and you can use our APIs by we provision them any which way you want it. You can pay per use, buy monthly plans, so you don't have to build your backend systems and spend hundreds of thousands of millions of dollars, or provision our APIs in your infrastructure, our SaaS products in your own infrastructure by licensing it. That's doable as well, but I digress there. So we use a variety of these offerings ourselves, as a B2B provider. We don't always go with, hey, we use AWS quite heavily, but that doesn't mean we use AWS for everything. Like we use DynamoDB, but not DocumentDB. DocumentDB is an Amazon persistent store along the lines of Mongo, but falls well short of Mongo. At least it did the last time we assessed and evaluated it. Now, I don't know how MSK is, and I think Confluent has some comparison here. You can look that up. Well, they say that not all Kafka services are created equal. I couldn't agree more. I don't know. I haven't checked out Confluent Cloud enough. It's only, again, 1 hour experience there, so I can't speak to it in particular. But I can speak to the what do I say, to that opinion or statement. I'm looking for the right word here. It does resonate with me, because you can use Amazon if you like single billing, unified billing. It works great, but sometimes you want particular value add and services. You might need to go outside of these cloud providers. For instance, we use MongoDB because if you're writing aggregates and complicated aggregate queries like we do for our chats, DocumentDB falls way short. At least it did, again, one more time when we last looked at it. So anyway, so let's say there are options out there, MSK, and you can probably look at other things. I'm sure there's more than one solution. We will look at Confluent Cloud today in this podcast. Some of the configuration and setup is kind of done, unfortunately, because of the previous recording that I mentioned, which where the screen share did not seem to have kicked in for whatever reason. So let's go through it one more time. Except that some of it is set up. I wish, I like to actually do it by clicking record without me not doing anything. That way we're learning together. Here, I'm an hour ahead of you, if you will, if you don't know or have never used Confluent Cloud. Now that we have the basic premise, let's get started. I signed up for an account. You know what? I drew this diagram in the last podcast as we went along, but here, let's start here. So what are the things we did? We signed up for an account, a free trial, and then the value add is it has plenty of pre-built connectors. That's why you want to use something like this possibly. even if it costs a little bit more money than using straight up Kafka. But obviously, you're always welcome to use just Kafka directly, or something like Amazon MSK, or one of the other multiple offerings I'm sure that's out there. Okay, so what did we do in the last one, and what are we going to look at again in this podcast? I'm going to be a tiny bit paranoid just because the last recording. Okay, it is recording. Okay, cool. Uh, he signed up for an account. Actually, I should maybe add that into the mix there. Signed up for free trial. So that is literally the first thing we did. And after that, okay. After that, the first thing we did after signing up was created a cluster. Just pick the basic, we'll look at that, I'm just going to go to that page, but at a high level, theoretical level. And again, we at Snowpal, we try everything practically and very pragmatic in our learning. We're not necessarily certainly not going through pages and pages of documentation. But if you did prefer that, there's no single right answer. You can actually go look for Confluent Cloud documentation. I think they have plentiful documentation. You can go through all of these pages, get your understanding, and learn it the more traditional way if that's your preference. We do look up documentation only when we need it. We feel personally, again, it's not necessarily the right or wrong answer. It slows us down. We are better off just giving it a shot, checking things out, and then making our own decisions based on our hunch and prior experience. But this is, there's no one way that serves everybody, right? So the documentation looks actually pretty good. I haven't looked at that, but going with the layout here and just looking at this, I'm pretty sure that they actually have pretty good documentation, and we can even explore that at the end of this podcast. Okay, we create a cluster, a very basic cluster in the part of the free plan, possibly so. The next thing we did was generated the API keys for use. Once you create the API key, they give you an option to have a global key or a more granular access key, depending on what you want somebody with that API key to be able to do. So you can create multiple sets of API keys, key and the secret, and then use it accordingly. So we have the API keys, create, you just hit generate, and we'll just see it there. Something you don't want to share with anybody, obviously, but in our podcast, I might still share it just because when you click generate, it might just pop it. And I think it showed the key, if I remember correctly. But, I'm going to anyway delete those keys at the end of the podcast, so it doesn't matter. The next thing we did was created the topics. There is a default topic created out of the box when you go through the configuration and the click steps. But we did create a couple of topics on top of them. We created the topics using curl and Postman. Their examples use curl, I believe, but I want to show it on Postman as well because a lot of people use it. It's an easier way to understand some of these REST integrations. And then we looked up the curl command. Let me jump here. I'm going to skip a few steps and come. So this was the curl command. It said how it had a post curl request to create a topic. After that, I just took that URL and then did a get, and then it returned a list of topics we had created. Now, again, I didn't go look to see their REST documentation, the API documentation to figure out what those REST endpoints were. Again, you could do them in a traditional manner, but sometimes you make these calculated guesses and hunch, and how things could have been implemented. So it kind of moves things along quicker, if you know what I mean. So we discovered there was a fetch version of it, not complicated, just do a get and not have a body. And then we also send messages to the topic, or produce records as the documentation phrases it. They're verbiage, but it's one and the same thing. You send a message to the topic. We didn't get as far as the subscribers. I didn't want to do that in the very first podcast. We'll see, given that I'm doing a recap here, we're moving along a whole lot faster than I did the first time around. So maybe we'll have some time to do the subscriptions, or even if we do, we might just choose to do it in 2 of N in this, Confluent Cloud podcast series at Snowpal. Okie dokie. So that's as far as diagram is concerned. I try to draw this. Sometimes, it takes a little bit of time. I drew this while I was doing the recording. So it gives folks the time to digest some of what we are chatting about here rather than just rushing through in a 10-minute edited podcast session. Um, but that's it for this diagram. There's a couple of more windows I have open here. Let me say that. I stumbled into ksqlDB. I've used Kafka quite a bit actually, but I haven't used ksqlDB. So I looked up what this was, and it's quite interesting. It says the database purpose built for stream processing applications. So I guess I saw that the Confluent Cloud offers ksql connectors, so we can probably check that out as well. If not in this podcast, in the subsequent one. It looks like you're writing SQL to deal with messaging essentially, right? That's how I read this as. So it looks quite interesting, and we will look that up. Apache Flink has not as much to do with this, but I stumbled into it yesterday when I was looking at something else, and it looked very interesting. It's a stateful computation, framework. It says stateful computations over data streams. It's also a distributed processing engine for data streams, and they have something called unbounded and bounded data streams, and it looks very interesting in the context of what. Let's see, maybe they have some connectors for Flink on Confluent Cloud. We'll figure out. If not, we'll do these separate podcasts for ksqlDB, for Flink, and so on and so forth. Okay, let's go here. Okay, now that we've seen the diagram, let's start here. So the first thing I did was signed up and created a cluster. And then after I created a cluster, let me go into, see, it says the cluster has been created. I just picked the defaults for this cluster. And once I did that, one of the first things I did was, before I went to the API keys, I want to pick a connector. Where are the connectors? Yeah, here. And I picked the simplest of connectors. They have a bunch of connectors. You can see all the connectors here. For Amazon, there's an Amazon S3 connector. It's basically, you can look up all of these connectors. There's one for MongoDB, for Snowflake, Postgres, Elasticsearch, AWS Lambda, and that list goes on. This is the value add that you get by actually using something like Confluent. Now, I don't know whether Amazon provides such connectors in their world of managed Kafka as a service. Maybe, maybe not. Maybe that could be one of the differences as to why you might want to go the Confluent route versus the Amazon. Was it MSK? I forget. Amazon. Yeah, MSK route. You should look it up. I'm not sure if they have such connectors. So I picked the simplest connector, sample data connector. And what happened was it was just a JSON connector. It gave me an error after I picked select. So you might see the same issue. They might have a bug here. And I said, okay, let me just repeat the same action again, going against Albert Einstein's code, which is repeating the same actions over and over again, over and over again, and expecting different results is insanity. Probably true. Probably it was when Einstein mentioned it, but maybe if he were alive today, we would, he might write it a little bit differently, because I've seen things can be different even if you did the same thing, because a lot of other things changed, because your actions are quite the same, but something else that's not transparent to you, or that is transparent to you, actually changed in the background. So the end outcome is actually different. So I deleted the data gen connector because there was an error. It did not do a clean delete. Let me make sure I'm still sharing this time around. Okay. It did not do a clean delete. And it left a lingering topic around sample data, which is the default topic that I guess it creates when you actually create this connector. I don't want to delete it. I said, okay, maybe I'll just go ahead and start using it, and things were working. So that error was benign error. But there is a bug for sure on the Confluent Cloud data connector for the data gen at least. And then when I tried to delete it, it did not do a clean delete either. So there's certainly one bug. There's more bugs, if not, one bug, if not more, is what I'm trying to say. Okay, and then we created some topics, and they had shared like a curl command. So I took the curl command here. Here is what it is, and created the topic. So they have an authorization here, and then there's a URL. It's PKC blah 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 Confluent Cloud. This is the URL to our secure cluster. Now in the real world, when you're going to using it in your product, in the lower environments, the higher environments, you're going to have your own DNS. configured so the URL will look prettier than it is right now. But that's outside the realm of this conversation. It's not important for this podcast. I'm just going to ignore it, or at least not speak more to it. And then Kafka version 3, I guess, clusters. And LKC, this is the cluster ID. This is our cluster ID that it created. And then /topics, we were doing a post using this message body, and it created a topic. Now I took the same thing over in the previous podcast, took it over uh, to Postman, and then added an authorization header. Just took this authorization, added that as a header, and copied the value, and actually added it. Now let me send the request. What topic did we give it a name here? Okay, this is just topic, and let me run it again. It's going to say topic exists. Now I notice that it's case insensitive. So if I do podcast topic, it'll still go through, even though it's the same. But I wouldn't recommend that you use topics that are named identically, except for the case being different. Is going to make it more confusing. And then the response here, let's look at it for a second. You see that it's got the kind, it says Kafka topic. It has a cluster ID, the name of the topic, and then the partition count, which, as I understand, is the default partition count when you do it on Confluent Cloud. So if you go to any of this topic here, let's pick a topic. Actually, I already have the connector, so I'm just going to go. This is the topic API key, and then the secret. Don't share it with anybody. Let's see, where do I go to see the list of this is the connector, so I should probably go to topics. Yep, I go to podcast topic A, and you go to configuration. You see the partitions. If you edit the settings, it says number of partitions as default is 6, so that's what's showing here, the partition count. And then there's some more metadata here, but this self URL I actually mentioned in the last one. If you search for Hetios, hopefully I'm pronouncing this right. It's a hypermedia as the engine of application. So it's a constraint of the REST application architecture, which if you haven't used, check that out. It's a way to return RESTful responses and have these embedded URLs as links, self links, which lets your client, whether it's human or a machine, discover more about what they need to discover in lieu of documentation, if you will. I'm explaining that in layman's fashion. I've used that, and it's quite interesting. So if we have a REST URL, just to digress for a minute, let's say give me /restaurants, a list of restaurants, and then you get a list of restaurants, and within the restaurant response, you could have actually a self URL that points to the restaurant's ID. That way, the subsequent call can be discovered through the response of the previous one. Now, this is probably worth a quick podcast in itself, so I won't go into much of the details. But just looking at this response quickly, that's what it tells me. It's at least along those lines, where it tells you what this URL is. It's a self URL, and there could be more such URLs if they wanted to take Helios to the next level, to let you explore these subsequent endpoints. They don't have it here, but they potentially could. Now we added a new topic. Let's go back here. I'm not going to look at that new topic that we added. I'm just going to go show you that after that, I ran another endpoint, which is exactly the same URL, changed the verb to get and run the request. And then it basically gives you all the topics that we created. Now there are, again, there are the cluster IDs that is the same across all of these topics because we only have a single cluster. There's a topic name, application factor, and topic. We can look up what this one means in the context of what we're talking about here. The partition count we have already seen, and then the rest of it is just all of that as a response, right? You can run it however you want. I'm just doing it on Postman. You can do it on curl through your tools and whatnot. And again, before, it also gave me an option when I went through the exercise. It said, hey, do you want to go with a particular language? It had a list of languages, with REST being one of it. REST is not really a language, but I guess the UI just showed it as a language. You could pick Go or Node or Java, and we might do one or more Go probably because that's mostly what we're using at Snowpal now for building our backend systems. We have a large ecosystem of a variety of different kinds of languages and technologies and frameworks. We are a polyglot shop. With that said, a recent law has been with Golang as a language, with how it performs, how nice it is to actually write code in Go. So a lot of our recent SaaS products and APIs have been built exclusively on Go. So probably we'll do a session on Confluent using Go as actually a language to try out some examples here. I picked REST for this particular first podcast. So we got a list of topics. And now the next endpoint here, and again, I think I captured it. So Kafka V3 clusters topics. If you see this one, it's clusters. Let me copy this. Clusters, cluster ID, topics, and then topic name, and then it says slash records. That basically is where we are posting all of posting our messages to. So this is the body. The body is a little bit unusual if you ask me, because it says value and then there is a type JSON. You can pick multiple data formats. It also had protobuf as an option. And again, if you don't know what protobuf is, protocol buffers, look it up. It's actually in the context of Go. There's some really nice. If you want to do message exchanges, you can do them traditionally using JSON as well, but using it through a binary format like protobuf makes it much faster. So if you're communicating between Go services, for instance, you certainly want to check out the Go protobuf protocol buffers. So I picked JSON. So this value says type JSON and then there's data. But the structure of this message doesn't seem quite right to me. It's at least my opinion. Because we picked JSON, so it tells when you're calling this RESTful endpoint, apparently it needs to know that it is JSON. Sure, it doesn't want to inspect and discover, but it needs to tell you. But I would have thought that this should have been on the outside of this value and not the inside. At least that's me. Anyways, there is this data, unless I'm missing something here, which I'm maybe not. So we published a bunch of messages. Let's actually publish, since I'm starting this podcast again, let's publish one more. There we go. That's message number 9. The size says 45 bytes. Now it's going to be like 46, right? So we published more messages. You can, we'll not get to the consumer part most likely in this podcast, but definitely in the subsequent ones, in 2 of them for sure. So we published, added records and sent it to this. Which topic did we send it to? We sent it to topic B. So let's step out of this topic, go to B. It self refreshes this page so you can we can view the messages. Yeah, that's the most recent to be sent. And now there's a notion of offsets and partitions. You can look that up, look up Kafka documentation if you're not familiar with that. But I think it should suffice to know that you'll see a unique combination here. Like every time we send a message, let's say this one says partition 5, offset 1. Let's see the next one is going to partition 4, offset 3. There's up to 6 partitions. So starts at 0, 0 through 5. The default, at least from what we saw earlier, when you create this topic on Confluent Cloud. And then the combination of this has to be unique for that message. We'll talk a bit more about the partitions and offsets and all of these terminologies, Kafka terminologies and messaging terminologies in general to a large extent when we go to the consumption. But it should suffice to know that this combination will be unique. If, as you see here, all of these 03, 04, 05, 14, 00, 13, 02, it is a unique combination. And if you don't believe me, let's do it on 1 and 1, which means there wasn't a 1 and 1 before, and this is the first 1 and 1, and it'll show up here in a second. There you go. So those are the messages we are sending to this topic. Now, we didn't run this locally in our infrastructure. We just created a cluster. Within 10 minutes we were able to actually create a topic through code or through the REST command line or through Postman, and then create topics and start sending messages, and now we can start adding consumers. That's how quick it is when you're using these managed services. But not only that, it also they provide a lot of these connectors, right? We've just used the base simple connector, but by virtue of having these pre-built connectors, it makes you're spending all of your energies and time solving your core customer problems, right? Not standing up the infrastructure, standing up and provisioning and configuring and managing it. All of that is not worth it. The smaller you are as a company, the more you want to do, it's not worth it at all. But even for larger organizations, you rather spend the time, money, effort, and resource on items that actually could mandate those warrant those, as opposed to reinventing the wheel. Which brings me to a little bit of a snowpal pitch, if you will. Let me go here, stop share, and I should remember to share again. If you're building systems, mobile apps, web apps, microservices, you can take the pain, time, effort, money, and all of that to build, design, architect, develop, implement, test, and deploy and manage backend systems. But it may or may not be worth your while and time and money, because that's what we do at Snowpal. Provide these a suite of APIs and SaaS products, so you don't have to do it, and you can go to market really, really soon. Um, so definitely check out our products on AWS Marketplace, uh, on Blobber API Hub, and there's a number of different places. You can go here. It's very simple. You get the API key, and within the first 5 to 10 minutes, you can actually start consuming our APIs. There's a number of APIs. They are generic building blocks. They are horizontals and verticals, and you can pay per use, consume it paying by a monthly plan, or you can actually provision our products in your own infrastructure and make it part of your unified consolidated AWS or other billing structures and patterns, if you will. How you deploy it and use is entirely up to you. So we are to our products as MongoDB Atlas is to MongoDB and Confluent Cloud is to Kafka, for instance, right? We are managed providers of our own SaaS products and services. Okay, now let me go back to sharing again. Okay, cool. Now let's go back here. I think this was just me having exploring the messages, but we've seen, so I can close that one. We've seen the diagram as well. Okay, we saw the messages. What else, right? The API keys, again, you need to you create an API key. You can grant, when you go to create an API key, you can choose global access, meaning allow your key to access everything, right? Access everything, which not the safest. It says recommended for development, right? Obviously not for production. When you go to production, create a different key, granted granular access, and use those keys. That's one thing. Cluster settings. This gives you details about the cluster ID, the Bootstrap server, and the REST endpoint. This is the endpoint that we are using here. This is the example we took, Kafka REST API to interact with your cluster and produce records, because it's quick and easy to check out. And then it gave me an option to choose any cloud provider. I literally did all of this by clicking through in the last podcast. My apologies that it went, the screenshot didn't happen. So I'm actually speaking to it as though it's theory, but it's not. We created this like an hour ago, literally. So it gave you an option to pick any of these three cloud providers. That they have support for AWS, Google Cloud, and Azure. I picked AWS simply because a lot of our services at Snowpal are on AWS, and that's our comfort, just like Comfort Food, that's our comfort cloud provider. But might have just as easily pick the other two. Stream Lineage. This looks to me like it is actually a graphical way to sort of look at what's happening, a representation of your streams and data and messages and whatnot. It looks all right, but when I stumbled into this. I mentioned in the last podcast, the one that did not get published because of the reason I've said like 3 times. I know, sorry. Is that we probably will do one on Datadog at some point. Datadog is a beautiful, lovely observability platform, and I'm pretty sure they have support for Kafka 100%. And if they do, probably a single consolidated place for you to manage this, so you don't have to go to 10 different places to manage. Like, for instance, we use MongoDB Atlas. MongoDB Atlas also provides a a graphical interface like this, uh, you know, an illustrative interface, that's the right word, to manage your collections and whatnot. But again, do you want to log into 10 different places and do it, or just pay for something like Datadog, as expensive as it might be, and do it there? It's very developer friendly, so I would actually recommend it. Okay, so that's what it was as far as. Oh wait, hang on. Let me go to cluster. Oops, sorry. Environments. Go to cluster. Okay, and then we go to, yep, that's the stream lineage. Um, Stream Designer, it says it's a low-code visual interface to build, run, and monitor data pipelines. This looks cool as well. So we are going to check this out in the subsequent podcast. Topics, this gives you a list of all topics. We created a number of them. And then I don't know, maybe did we do a fetch? I think we did a fetch of the topics as well. And then we sent messages or added records to certain topics. We look at ksql DB, how stream processing works. Uh, uh, let me read this out. Stream processing involves ingesting a continuous data stream to analyze, filter, transform, or enhance data in real time. ksqlDB makes it easy to allow you to do this with a familiar SQL syntax. I think that's what I assumed, right? Remember, I mentioned at the top of the call where there was this tab open with ksqlDB where I said it's being able to interact with Kafka in a SQL manner. So we can look that up as well, and then we'll check out a bunch of some connectors. At least they have a long list of connectors. I don't know if I ran through this in this podcast or the previous one. Let me do it. They got one for Amazon, for Elasticsearch, MongoDB, SQL Server, Postgres, ActiveMQ, Lambdas, you name it, probably have it. This is again value add, that by virtue of using these managed providers, especially it's created by the original creators of Kafka themselves, right? That's this list here. Trying to think what else to explore. We have not created any consumers yet, so we just created the messages, the cluster. We created a topic. We posted messages or produced records into that. Posted it to those topics, and we actually looked at the messages. Now in the previous one I did one more thing. For what it's worth, let me actually show that here. Now let's say I want to consume the message. What if I just do a get on it? See what happens. It returns a 405, exactly what you would expect, because you're actually this is we're using Kafka, right? We are sending messages using a RESTful client, but the messages cannot be consumed this way. I would not have expected for them to have been able to be consumed this way. You have to register these subscribers and start consuming the messages at real time. So I expected a 405. 405 is, if you do not know what that error stands for, it basically says the server understood our request, but the target resource does not support this method. I don't expect for it to support this method. Okay, let me delete that. What else? Let's see. I guess we're like 40 minutes in. So we've saved about 30% time. That's what it is. It took 30% longer to have done this the first time. That's the time we've saved, but I've gone through the list here. The only difference is we didn't do the actual clicking while the video, while this recording was done. Before I end this, let me see if there is anything else we can look at here. Let's see, go to topics. We talked about it being case insensitive. You could create multiple topics with the same characters, which I strongly recommend, highly recommend you don't do. It's going to cause confusion. Okay, schema. We didn't create a schema. We can actually, set a schema, which we'll probably do as we go. Configuration. I think we already saw this. There's also a full config here. And then if you want to modify the defaults, here's what we would typically do at Snowpile. We would just go copy this literally, and we would just do Kafka or Confluent. Pretty sure it's Confluent. Right, and then you can, I'm trying to go to the doc. I'm just going to show how we could go to the documentation. Let's see. Maybe this one is probably replication throttled replicas. We'll let us see how to modify some of these settings. I'll switch to expert mode. It doesn't let me modify a lot of these. I wonder if it's because I'm on a free plan, or maybe the cluster is like the most basic of clusters, because it doesn't say why those things are unable to be changed. I wish it. Oh, not. Be careful not to get your topic in a bad state. You have control. I wonder if it doesn't let us do it because we already have mess. Not sure. Let's say we had a topic here, topic 6. You can change the number of partitions, advanced settings, blah, blah, blah. This topic defaults. Replace your data. This setting is logged. So they are logged. I had to figure why. That is strange. Topic not found. We just created the topic. Yep, their UI has issue. I mean, it's not UI issue. I'm just saying you run into issues. It's probably, I don't know, likely a backend issue, a bug that they need to fix. Okay, so I don't know why some of those other attributes are not modifiable. I wonder if it depends on the plan we're on, possibly. It doesn't let you customize it, or I wonder if it's the default cluster that I created. Probably unlikely. Probably it's the plan. So topic wise, we looked at configuration. Actually, let's delete the topic here. Topic name is topic_6. Okay, that's gone. And of course, if you try to post a message to a topic that doesn't exist, you can see what kind of. So I tried this earlier. It actually took a while. I know it's going to time out at some point, but I would have expected it to throw an error, not like spin for this long, but it is what it is. So that certainly I've run into a few of these issues. Okay. Wait, no, maybe podcast topic C doesn't exist as well. A exists, so I posted it there. Okay. I think, so at the beginning of this 50 minutes, right? We're 50 minutes in. Not 50 actually, only 40 minutes in. At 40 minutes ago, we didn't know anything. At least I didn't know. At least 1 hour ago, I certainly didn't know anything about Confluent Cloud. I just re-recording it, so I knew a little bit about it. But an hour ago, we didn't know anything about Confluent Cloud. Ideas at the end of these podcasts, each of these podcast sessions, if you will, the end of the 45 minutes or the half hour or the 1 hour, or sometimes it goes to 2 hours. I think the Terraform one, or probably was one of the Salesforce podcasts. I can't remember. It was like pretty long. But the end of that, even if it's long, it's only like an hour and a half or two at most. I know at most. Most of them are hover around the 1 hour mark. The idea is you come out with some learning, so you know what it is, what are the pros, some cons. We tried do some hands-on work, get it running, get it working, to digest it, so we're not ignorant anymore at the end of that hour, which I think is a good place to be in for any new technology, if you ask me. And that's the idea behind me recording us recording these podcasts. There are times we use, let's say we're working on a Go API with some Kafka dependency deployed, persisting to Mongo, and we have run into issues or fix some things or have a nice feature. We come back and share that with you in a podcast. That's something that's working and in production. Other times we pick tools and technologies we have nothing to do with, at least not yet, and then start exploring it. Some we may or may not ever possibly use. It's a dramatic statement to make, but I can tell. Confluent Cloud, I'm seeing value in it already. But some of the Salesforce services that I saw, I didn't take a liking to some of them. Data graph was actually not too bad, even though the user interface was not particularly impressed. So you can, just learning together, as opposed to me knowing some things and only coming and trying to share that knowledge by quote unquote teaching. I say quote unquote because I'm not a teacher. Hopefully I'm not doing a sloppy job here. It's a phenomenally noble profession, and you need to have that skill to be a teacher. Some of us just try to do a bit of teaching, but we fall far short of being anywhere near these brilliant folks who are teachers. Anyway, so that's the idea, and hopefully you know something more about Confluent Cloud than you did 45 minutes ago. At least that's my hope. check out our our products, APIs, and whatnot. We have a ton of products. One thing I would say is, let me share my screen one more time, and if you go to products.snowpal.com, just subscribe to it. I'm not in incognito, but if I were on in incognito mode, this is what it's going to be. So just put your email so you don't miss any updates uh, about our podcasts, our APIs, our SaaS products, our mobile apps, our web app, our courses. We have a course platform, so we have a large ecosystem. So definitely, subscribe. That way you can keep up to date and with skills and technologies and with what's happening in our company and be successful along with this as well. That's it. Thanks for watching. Talk to you later.